Hello friends, welcome back. In this tutorial, we are going to discuss Introduction to Hybrid Programming Languages. We know that high-level programming languages are either compiled, interpreted, or hybrid languages. In the previous tutorials, we understood that to translate a high-level programming language code to a machine-level programming language code, if we use only an interpreter, then such high-level programming languages are known as interpreted programming languages. And to translate a high-level programming language code to a machine-level programming language code, if we use only a compiler, then such high-level programming languages are known as compiled programming languages. Similarly, to translate a high-level programming language code to a machine-level programming language code, if we use both compiler as well as interpreter, then such high-level programming languages are known as hybrid programming languages. We learned that interpreter translates and executes code line by line, whereas compiler translates the entire source code to a machine code first, then that machine code is executed by the CPU. Interpreter and compiler both are translators used to translate high-level language codes to low-level language codes. With respect to hybrid programming languages, compiler and interpreter are going to work slightly different. Here, instead of generating an exe or a machine code, compiler takes high-level language code as an input and generates an intermediate code. Then, interpreter takes intermediate code and generates machine code. Normally we say native machine code, and that machine code is executed on the system. Here I have listed some example programming languages for hybrid programming languages. Java, C#, ActionScript are hybrid programming languages. To write codes for micro devices, Mr. James Gosling has designed Java programming language at Sun Microsystem around the year 1996. Based on the Java programming language, many other programming languages have been designed like C#, ECMAScript, ActionScript. Java is a hybrid programming language, hence it uses both compiler as well as interpreter. As we are learning Java is a structured general purpose object-oriented programming language. As Java is an object-oriented programming language, object-oriented programming languages are going to implement a concept where everything should be part of an object. Everything should be written within a class. You can see that here we have written a main function itself inside a class. Functions in object-oriented programming languages are known as methods. Instead of procedures or functions, we should say methods in object-oriented programming languages because they are written within the class. We discuss about what are structured programming languages, what are general purpose programming languages, what are specific purpose programming languages, what are object-oriented programming languages, meaning later step by step. Let's discuss how a Java programming language code is converted to a machine code in this image. If you have written a source code in a Java programming language, normally Java files are going to have an extension .java. We know that compiler is going to take the entire source code as an input. So there is a compiler called as Java C. Java C means Java compiler. It takes the entire source code as an input, scans and translates it to an intermediate code which is known as bytecode. Normally it generates another file with the same file name with an extension .class. So .class files are actually intermediate codes or byte codes which are only understood by Java Runtime Environment, that is JVM, Java Virtual Machine. So that bytecode is understood by the JVM. Hence, JVM takes the bytecode as an input. In the JVM, you find a Java interpreter. Java interpreter is going to translate and execute the bytecodes to a machine code line by line. So it takes next line, translates it to the machine code and executed by the computer. Takes the next line, translates it into the machine code and executes on the platform. That is how the Java source code is converted to the machine code and executed. If you have another platform, maybe similar platform or some other platform, to execute Java programs, you need not to shift the source code. You don't need source code to be shifted. So hence, source code is secured. Only thing you need to do is you need to shift the bytecode, that is .class file, to another platform. Maybe it is similar or not. then that bytecode, as we know, that is understood by the Java runtime environment, that is Java virtual machine. There we have an interpreter. So interpreter understands automatically the underlying platform. It may be a similar platform or other platform. Automatically interpreter, based on that platform, it translates the bytecode to the machine code line by line and executes. Translates to machine code and executed. And also you can see that you need not to modify the bytecode. Hence, Java is a platform independent. We need not to worry about the underlying platform to write source codes. Hence, Java is a source platform independent. We need not to recompile the Java source code on different platforms. Hence, Java is a bytecode platform independent. Normally we say Java is a platform independent, but Java is partially platform independent. The reason is, to execute the Java codes, you must and should need Java runtime environment installed on every platform. If there is no Java runtime environment, then Java source codes can't be executed. Hope you guys have understood. Now we discuss some advantages of hybrid programming languages. As we know that hybrid programming languages are easy to learn, easy to code, easy to remember, easy to understand, easy to represent real world entities, more reusability, more extensibility, and more maintainability is present in hybrid programming languages. As hybrid programming languages use compilers, compilers provide list of errors for easy debugging. Compilers execute hybrid programming languages faster. Less memory is required because compilers perform code minimization, code optimization. They generate lesser size of codes. Source code need not be shifted for execution, maybe on a similar platform or maybe to a different platform. We need not to shift the source code. Hence, source security is present. Hybrid programming languages are platform independent. They are source platform independent because to write source codes, we need not to worry about the underlying platforms. To execute the same code on another platform, we need not to readjust the source code. We need not to recompile the source code. Hybrid programming languages are intermediate code platform independent because we need not to readjust or remodify the bytecode generated or intermediate code generated, because the interpreters present in the platform is going to translate the bytecode automatically to the machine code based on the platform on which it is present. So that is how the hybrid programming languages work. Hope you guys have understood. For this tutorial, this much is enough, friends. For more benefits, please subscribe, like, comment and share these video tutorials with others so that everyone will get benefited. See you in the next tutorial. Keep learning, keep coding, keep sharing.